Okay, so here's example 4.3 that I did in the video and just kind of showed some things by hand. But you'll probably want to use technology for these kinds of things to do the calculations. So again, this was a bag of potato chips, says 130 calories, but you sample 35 bags and you get on the average 134 calories with a standard deviation of 17. And so they have their hypothesis test here. They compute the average, or they look at the average and get the standard error and so forth. So I went ahead and I set up a spreadsheet. It doesn't take a whole lot. So I have my hypothesized mean, I have my sample mean, sample standard deviation, my n. And so, those are just my data. I'm going to need those every time. Now, we could also see that I might have real life data to get some of these numbers from, but on this particular problem, all I have is this. So I need my standard error. Well, again, standard error is just my sample standard deviation divided by the square root of n. So I type that in. I say equals. And I go up here and get my standard deviation and I divide that by the square root of my n. So I click on that, hit enter, and there is the 2.87 that they mentioned. I need my degrees of freedom. Now I could just get that when I need it by subtracting 1, but I might as well just take my n and subtract 1. And so I have my 34. The t that we need to compare with, using our distribution. Again, that is just the difference, but I want to use an absolute value because I'm doing this two-sided thing, and I think it has to be a positive number that goes into the t distribution command anyway. We can try it without just to see what happens, but I need an absolute value, so I'll write ABS, open parenthesis, and I need my sample mean minus my hypothesized mean, and then close that off and divide by my standard error. So there's my standard error. I can't see it here. It's up there. No, that didn't do it. So anyway, I'll just try hitting enter. I accidentally changed that to C5, but now you can see that. Okay, so there I needed to divide by my standard error. So there's the B5, and hit enter. And there's the 1.39 they had. And now to get the p-value, I need the t distribution. So it's just equals, and it's the tdist command, tdist, open parenthesis, and it says, okay, I need the number. Oh, there's my t number right there. Then I need my degrees of freedom. Oh, I have that right there. And then I need to know whether it's a one-sided or two-sided or two-tailed. So I have a two-tailed, two-sided test. And so that's what I need. In parentheses, I hit enter. And you see, it is a little different than the book. The book got 0.16, but that's because they used the normal distribution instead of the t distribution. And we could try that, I guess. Equals norm dist and number. Okay, the number's still the same, doesn't change, comma, the mean of my distribution, standard normal distribution, so that's a 0 and a 1, and oh yeah, see, this is a little harder to work with because this is going to give me the cumulative. It's going to give me the left-hand area. So, it's kind of a pain. So, so I'll go ahead and put a 1 for the left-hand area, but now to fix that I need to do a 1 minus because I wanted the right-hand area, the stuff outside. And then though I need 2 tails, so I'm going to do a 2 times and put a parenthesis. So see, just go with the t-distribution, right? That, and there we get there 0.16. Okay, now if you want to do the z with the easier thing here, okay, this was so much easier to put stuff in and get an answer. Oh, if you want z, degrees of freedom, just if I want to compare to that 0.16, I'm going to put in here 1, 2, 3, 1,000 degrees of freedom. Enter. And see, they are still just slightly different. But they are really close. And you know, if you weren't happy with that, hey, try 10,000 degrees of freedom. Now we're getting somewhere, at least to what, 4 decimal places, 0.1639, 0.1639. So that is showing that the t distribution is heading, as I increase degrees of freedom, it's heading toward the normal distribution. But I'm going to put this back to being my degrees of freedom right there. And so that is a perfectly good answer for this problem. Again, the textbook used the z distribution, which is fine because the sample size was 35. But if you use the t distribution, you'll get an answer that's pretty similar, right? Again, we fail to reject the null hypothesis, and there you go. But there you can use the t distribution within this. It doesn't take a lot, right? I need to enter these 4 items, and then once I've entered those, I can compute the standard error and so forth. So, you know, so I'm going to get rid of this. You know, and now though, since I put this in, if I save this as a file, I can just come in here and say, oh no, my hypothesized mean is 50, my sample mean is 52, I have a standard deviation of maybe 3, and maybe my sample size is 19. And with that, okay, it calculates the standard error, the degrees of freedom, the t statistic. So maybe I'll write that in here, statistic, just so I can remember. And then a p-value. Turns out the p-value, and in this case, if these were really what was going on, I would be under 0.05 and I would reject the null hypothesis. Okay, so once you have this template in here, it's pretty simple. And I can even go a little further than that. Suppose I put in some random numbers, you know, so I'm just going to do this for, pretend this is really data. So rand between, let's go with numbers between 0 and 10. And I'll make 10 of those. I don't know if I have 10 or not. Here I can go like this. 1. There's 10. So there's my 10 random numbers. Now from those 10 random numbers, I could actually in here say, oh, I want the average, and I could do it that way, or I could just retype, you know, I could get the average and then retype the number. But there's my average, 3.5. I could get my standard deviation, deviation, STDEV, of those 10 numbers. I could toss in now 10. Now I could even count them. I mean, I know I have 10, but I could even go something like count and highlight those numbers, and it should give me 10. And there's my 10. And now, if these are random numbers between 0 and 10, I really should get an answer of 5. And notice that with just 10 of them, even though I'm way off, I've got a sample mean of 3.5, that I get a p-value of 0.185. So as far as I can tell, yeah, those are random. I certainly don't have evidence to say they're not giving me a mean of 5. Okay, I mean, it certainly didn't this time. But maybe next time it will. I don't know if I double click in here and hit enter. That didn't recalculate. My particular, maybe if I just put a 4 in here and do that, no, that didn't recalculate either. My particular spreadsheet does not recalculate really easily all the time. And so probably if I probably even just edited out one of those B's and retyped it and hit enter, then it recalculated to 7, but it didn't recalculate anything else. And so I would have to do some things to recalculate. Possibly, well, how about this? I'll copy it, so I'll do a Control-C, and then I'll paste it, Control-V, I'll say yes, and oh yeah, there it redid it. And that time I got a mean of 5.8. And again, a big p-value. Okay, so if I have real data, I can still change this thing to just put my sample mean there, my sample standard deviation there, and if it's a pretty big set of data, I can even do the count thing there where I have it count the number of data for me. Okay, but counting's not so bad, if I just put numbers beside the data. All right, so that is using Excel to perform my hypothesis test.